Assalamualaikum warahmatullahi ta'ala wabarakatuh and have a very good day. Today, I'm going to share with you on sewerage design calculation. So this video a bit longer because I will give an example and using a spreadsheet how to do a sewerage design calculation. So the content, of this design calculation is the first one is to propose the sewerage line layout plan, location of the manhole with design detail information, design calculation using spreadsheet, detailed drawing, and the design report. And I am also will share with you the submission process of the sewerage approval. So for example, I do have this layout plan. So you should have your own layout plan. So for the whole project that you are going to design. So you have to identify the location or the location of your manhole. So in the previous video, I do already share with you actually the location of the proposed manhole. So you have to fulfill the requirement of the proposed manhole with the perfect location and the suitable location in order for you to distribute the sewerage line. So in my case here, so I will start our manhole here, and then you have to put your ground level here. So in order for us to know what is your ground level, in order for us to calculate or determine what will be the invert level for that manhole. So we have to know the connection of each manhole from the first one until to the discharge point. In my case here, I will discharge my sewerage or sewer wastage to the STP. So we have to know also the connection or the collection point, so that we will know the population equivalent for each building where are the location of this load will transfer to. In my case here, so the load from this building will transfer to this line only. So the main discharge from this building only to manhole 1 and manhole 2. Then the other one is just accumulative from the manhole 1 to the manhole 2. So if you would like, for example, to separate, if you would like to separate into two portion for the PE, you may do so. So for example, half to this manhole 1 and manhole 2, another half will be to the manhole 4 and manhole 5, or manhole 5 to manhole 8. So it's depend. So it's how you arrange. You have to arrange by yourself. So this drawing is not to scale. I just would like to show what are the information that we have to know from the key plan. So in my case, we have to know the grid line, the ground level, the location of the manhole, the length between the manhole. So this is the point. And then another thing is the population equivalent. So in the previous one, so I do already shows how to calculate the population equivalent and where we can get this value. So this is how we calculate the population equivalent, because this is the considered as a residential area. Then the consideration of the residential area built up with the residential and also commercial area. So this is how we calculate the population equivalent, because for residential is equal to 5% per area, and then because I have a 13 unit of houses, so we will have the total numbers of population equivalent is 65. So for the commercial area, so based on the square feet, so the PE per unit area is equal to 3 per 100 meters squared, therefore is equal to 70 times of this 1,700. That's why it's 17. So I'll got here 51 and so on. This is the total PE for the whole project. So this is the design calculation. Okay, the design calculation here, the first one, we have to calculate the peak flow factor. So the peak flow factor is equal to 4.7 divided by PE over 100. Okay, power of 0.11. I'll get this answer, 6.349 liter per second. And then we have to calculate the average flow rate, Q average. So it's equal to per capita daily sewerage flow generation, which is 225 is actually the per capita value for daily, which is 225. Time with the 65 is the cumulative PE, and then divided by the day. Day is equal to 24 hours. Okay, 1 hour is equal to 60 minutes, 1 minute equal to 60 seconds. So we get this answer. And then we calculate the peak flow factor. The peak flow is equal to peak flow factor time with the Q average. So all these step of the design calculation, we will transfer it into a spreadsheet that I will show to you later. Okay. So this is a sample of the calculation that you have to put in your report so that we will know how you calculate your every single parameter that we need to use in our sewerage design. So the design calculation, in that we have to determine the types of pipe. So in my case here, I'm using the vitrified clay pipe. So you may use a reinforced concrete pipe. It depends on the condition. So in my case here, so this pipe is limitation to the stable ground. So I consider as a stable ground. So how do we know this is a stable ground? So we have to check the what we call the bearing capacity of the soil, so that we know either the soil is strong or not. So if it is unstable, this pipe is not considered as a suitable pipe. We have to choose a different type that I do already shows in the guideline in my previous lecture. So what is the size? Okay, how about the joint, and then the suitable criteria that I'm choosing this pipe. Okay. So this is the diameter pipe. So please do try to start your diameter pipe from the smallest one, which is 2 to 5 millimeter. So if it is not suitable because of the discharge rate is higher, so you may change into the bigger size. Okay, so we have to check this diameter pipe in order for us to design the sewerage. So in my case here, so I'm using 2 to 5 millimeter. Try from the smallest dimension. Next one, we have to calculate the Manning equation. So in my case here, I'm using a Manning equation. So you may use any Huygens-Williams equation or any other types of equation. So from this equation, we have to calculate the velocity. So the velocity is equal to R squared, which is the hydraulic gradient, power of 2/3, and then time with the slope. Okay, R is the hydraulic radius. S is the hydraulic gradient, and then the Manning coefficient is from this table. So I'm considered as a new pipe condition. If it is an old pipe condition, you have to use a different Manning coefficient. So you have to calculate this Manning equation, and then this is the slope. Okay, 1 to S is the slope. Okay, this is the depth between the manhole 1. This is depth for the manhole 2. The depth is actually a different from the invert level to the ground level here. Okay, and then here is the Q, which is the discharge. Okay, discharge. Then this is the diameter of the pipe. Okay, this is an example for the information that we have to prepare in order for us to know the longitudinal section of our sewerage. So all the manhole here, okay, so for the first, for example, here is a one network. So from the manhole 1 to the manhole 10. So what are the information that we have to know is depth of the invert level, ground level, chainage, and then gradients, and then which is the slope, and then the pipes. Okay, so all this information is shown in this drawing. Okay, this is one of the drawing that required to be submitted to the local authority to get approval for the sewerage design. Okay, so this is the area. Area is equal to pi d squared over 4, and then weighted parameter is pi r squared, and then the slope is 1 ratio to n. Okay, 1 to n. So varies from 0.5%, which is from 50 or 400. So normally I will use 200 for my beginning design calculation. So it depends on how the condition of the site. So if it's really flat, sometimes we need a steeper slope compared to the area that we have a different level of the surface. So if the ground level have a different what we call different level, for example from the higher to the lower contour, so sometimes just use a gravity or the following slope. Okay, so following gradient due to the rolling terrain or from the top to the bottom. So if it is really flat, you have to really check carefully about your slope. So normally I will start with 1 to 200. So this is infiltration equal to 50 time with the pipe diameter time with pipe length over 1000 divided by 24 hours times 60 minutes times 60 seconds. So you'll get the answer. And then cumulative design flow, which is equal to peak flow time with the infiltration. This is the hydraulic radius is equal to area over weighted parameter. Full pipe velocity, just follow this equation. And then the level drop. Okay, so this is the pipe length that you have to prepare from the one manhole to another manhole. Then this is the ground level difference, which is the ground level from the start minus with the end. So if it is start from 3.2 and then the ground level at end is 31.1, so is equal to 2.1 meter. Okay, and then this is the design calculation in the example. Okay, the depth inlet level and outlet level. So how we going to calculate this, the depth of the invert level? Okay, the depth of the invert level is equal to 33.2 is the ground level minus with the proposed inlet level here. So in my case here, okay, so normally we will propose the depth of outlet level first. Okay, so for example, the minimum is 1.5 meter. So from the previous slide, if we can have a look here, okay, it may start from 1.2 meter. So if you would like to start 1.2 meter, you can start from 1.2 meter. So in my example here, so I'll start with 1.5 meter, at least 1.5 meter. Okay, it can be 1.2 meter. So how do I get this 29.6? So I take this value, ground level at the end, 31.1, okay, minus with 1.5 meter, I'll got 29.6 here. Okay, and then we know that the difference between the inlet level and outlet level, okay, the drop is about 0.16 meter. So to get this 29.76 is equal to 29.6, which is supposed to be is plus, okay, plus 0.16 because it is higher level because it at manhole 1, sorry. Okay, so it's supposed to be plus, so 29.76. Okay, so the difference, okay, of the invert level, okay, at this start is equal to 33.2 minus with 29.76. You get the depth for the first manhole is 3.44 meter. So therefore the depth, okay, at the manhole 2, okay, which is 1.5 meter. Okay, so you have to understand that. So here will be, okay, the depth of the manhole for the start, and then this is depth of the manhole at the end, okay, of that connection. So between manhole 1 and manhole 2, manhole 2 and manhole 3, manhole 3 and manhole 5. Okay, so for the second one here, okay, so if, okay, so we do calculate the level drop here 0.16 meter. Okay, the level drop is equal to 1 over 200, okay, time with the length, okay, with the length of the manhole between manhole 2 and manhole 3, I'll get the answer 0.16. Okay, so the different ground level is 2.1, which quite steep, okay, 2.1 meter. So here, okay, to start the inlet level, okay, at the second manhole, I need a drop 2 meter. So if I didn't do this drop 2 meter, the height of the depth for the outlet level here will be less than 1.5 meter or 1.2 meter. Okay, so because if I start here 29.6, for example, so if the ground level is 29, so means that your outlet invert level, okay, your outlet level will be higher than the ground level. It's not logic. So that's why we need drop another 2 meter below, okay. So means that 29.6 minus with 2 meter, I'll got 27.6. Then from the manhole 2 to manhole 3, I got 0.16 meter drop. Then I got 27.44. Okay, so we will continue this process by understanding between the connection of each sewerage pipeline. So please make sure that where is the cumulative point or intersection point. So if we have a look on the previous example of previous figure here, so this connection is at manhole 8. Okay, so the outlet level here, okay, at the manhole 8 should be satisfied to connect with manhole 7 and manhole 5. Okay, so it cannot be higher than manhole 7. It should be, okay, deeper than manhole 7 and also manhole 5, so that the water or the sewerage effluent will flow correctly to the STP. So this is the process that you have to do. So you may read and understand carefully the spreadsheet in order for you to really understand how do I use that value or calculate that value in those spreadsheet. Okay, next is the manhole drop. So the manhole drop here is depend on the location. So if we need it in order for us to satisfy the minimum 1.2 meter or 1.5 meter, so we have to follow the requirements. Okay, so the drop will make sure that the invert level have the minimum depth, which is 1.2 meter or 1.5 meter. Follow the requirement. Okay, so this is the detailed drawing. So how we do this detailed drawing? So this detailed drawing is connecting from the whole line here, okay, to the discharge point here. Okay, here is the discharge point. Okay, so at this drawing, so you have to include, okay, put in the value for your manhole numbers, the invert level, and then the ground level, and then here at the pipeline you have to put the diameter of the pipe and the length of the pipe. Okay, this is the detailed drawing, okay, that you have to include in order for us to know what are the sewer manhole, the dimension, okay, the trap, the sewer trench, okay, and the cross section AA and BB, okay, and then how the bedding, okay, the depth of the bedding, and then this is another detailing about the connection and so on, how they discharge from from the building to the sewerage line. Okay. So this is the sample of the design report. So for example, this is the sample of the design report. This is the content that you can follow. So I do already attach this design report example in your Microsoft team. Okay. So this is the project brief. So you have to brief about the project, and then the purpose of the project, the location of the project, the proposed sewerage system that you are going to use, including the sewerage treatment plan, about the population equivalent, okay, the design standard that you have to refer, and then the requirement that we have to follow in order. Normally, there is a certain requirement that is needed by that local authority, so you have to follow. So the guideline is there from the SPAN, okay, from IWK, so that you have to follow the exact guideline that is given by them, so that your design will be approved by them. Okay, and then this is the design criteria, which is the parameter that we have to calculate here. Okay, so give some the calculation example here. Okay, need only one sample for the calculation, and then we have to attach here the spreadsheet that we put in, okay, that we use. So this spreadsheet will be as a reference for the local authority to approve and check your design. Okay, with this calculation, okay, last but not least, so you have to attach all the drawing that is need in order for you to get approval from the local authority, especially IWK. Okay, so now I will continue on the submission to IWK to get the approval for the sewerage design. So there is a 9 stage actually, or 10 stage actually, but we have to check either we need it or not. Okay, so normally we have a PDC form 1, PDC form 2, 3, 4, 5, 6, 6-1, 7, 8, 9, and also handover sign off form. So we may check from this website. Okay, for the first one is the application for sewerage planning approval. Of course, we as a consultant, we have to fill up this form and do a submission. So after that, we have to apply this for the work of sewerage work or septic tank design approval. It takes about 1 month, okay, for both. And then detail for the structure, plan and design calculation. So we have to attach the structure so that the local authority may check the building condition or the building size so that they will know how you calculate your PE and so on, all this detailed information, the structure key plan, the key plan of the location, so that they will know you use an exact what ground level, platform level, or invert level that you use is correct, all those things. And then especially on the location of the manhole that you're going to put in your drawing. And then the detail of the electrical and design drawing is for the electrical, no need for us as a civil engineer. And then this notification for connection to public sewer, if we connect to the public sewer. If we connected to our internal septic tank or STP, so no need for us to do this application. So next, in between, we have to do an inspection. We have to fill up the PDC 7, so notice of intermediate inspection of the sewerage work. Either we, for example, so after we lay down all those pipe, okay, we do a bedding, connection, and so on. They have to check it first, and then they have to approve it first before, okay, we do the final inspection. For example, okay, in PDC 8, we will apply to the IWK. We have to submit the form that the construction is done. Then we have to get an approval by calling them to the site to do a inspection. In my own experience, previously we do a ball test. So we will put a tennis ball from from the first manhole, and then we will roll the ball and then we flush the water, and then either the ball, okay, can pass through from the manhole 1 to manhole 2 or not. So if until the last manhole, so means that if the ball can pass through all the line, so means that your design is correct, and then the inspection normally will be passed. Then last but not least is handover sign off form. So this is a sample of form. You may download this form from IWK website, the link that I do already share with you. So you may check by your own in order for you to understand well on the submission and also approval for sewerage plan. Okay, this is PDC 9 and also the CCC. So you have to get the CC so that your design is completed and approved. So that's it. So if you have any question, you may refer to me. So I hope that you understand how to do a sewage design. So please listen to this video carefully and try to understand the spreadsheet that I share to you in order for you to use to design the sewerage for the project. Thank you. Assalamualaikum warahmatullahi wabarakatuh.